You're listening to a podcast from the University of Cambridge Department of Engineering.
In this series of podcasts, we focus on creative partnerships, forged both within different parts of the engineering faculty and with outside companies.
It's a cross-disciplinary process which has led to some groundbreaking work both within the UK and across the globe.
It leads to the development of long-term relationships or constant creative collaborations.
A typical roadmap would have the time dimension looking forward into the future, and then a number of different layers which represent critical perspectives for successful innovation. My name is Dr. Robert Phaal. I'm based in the Institute for Manufacturing, which is part of the engineering department at the University of Cambridge.
So there's this confidence as an academic collaborator that I know that my research effort is well aligned with what they want to achieve as well. My name is Dr. Andrew Flewitt. I'm a reader in the Electrical Engineering Division in the Engineering Department at Cambridge University, and I've been working here for a number of years on electronic materials.
The kind of products we're enabling at Pragmatic are those that require some form of electronic intelligence, but where the form factor constraints mean that you can't easily include conventional electronics. My name is Scott White. I'm Chief Executive Officer of Pragmatic Printing. My career for the last 10 or 15 years has been as a serial entrepreneur. This is now my 6th technology venture.
Replacing existing silicon chips, cheap and lightweight plastic electronic technology could soon transform our world.
Imagine electronically updated food labels, computers embedded in our armchairs, even contact lenses linking us direct to the internet.
To bring us into the age of plastic electronics.
So we've been working recently on what we call transparent electronics. This is using a class of materials called metal oxides, which have the property that you can actually make both conductors and semiconductors and dielectrics, all the things that you need to make an electronic device. But the material itself is optically transparent, so you can make devices which you can see straight through.
These are things that may be typical consumer products that don't look like they have any electronics until you touch them or interact with them in some way, and then that leads to an effect. A light flashes or a simple visual feature is activated or something like that.
The main contribution from my side has been the use of road mapping to support Andrew with his strategy for exploiting the technology and research in his area.
At the very start, we had a road mapping session where we were essentially asking where are we going to go with this technology.
Road mapping is a structured visual representation of strategy.
You'll get sort of very enthused about it yourself, but it does you good to actually sit down every so often and articulate that with the group of people that you're actually working with.
We print the roadmap on a large wall chart and we provide everyone with post-it notes. It's a rather simple approach really, but it empowers the people in the room to contribute their knowledge.
And get a real sense of, where do we want to actually end up as a team?
It enables the group to identify the key opportunities that they see in the future and the routes to capture that value.
I first came across Pragmatic Printing at a conference which I think bizarrely enough was actually out in Tokyo, and Scott was one of the people who happened to say hello to me at the end of my talk.
Andrew was one of the first people that we came across working in the area of metal oxide semiconductors. The work that Andrew was doing in that area seemed to give a lot of hope in overcoming many of the challenges organic electronics had run into, in particular the performance and stability and consistency of the semiconductor materials themselves.
It was clear quite quickly that actually their sort of area was one that aligned quite nicely with the area of logic on plastic that we'd already identified in our road mapping.
We did an initial project, I think from memory it was about 3 months, looking at the specific metal oxides that Andrew had been working on and applying them to our device architectures. And while that didn't solve all the problems, it did give a lot of hope for where that could go in the future.
The first step is to articulate the opportunity. What kind of product and service potentially might be valuable? What kind of market? What would the actual product look like in the end? The second part of the workshop, which is really the heart, is to identify a set of logical steps towards that value.
The idea of embedding logic onto plastic surfaces was potentially really important.
What is the opportunity? What is the first demonstrator, and what are the next actions for the team?
There is a lot of synergy in the types of areas we're working on in terms of device characterization and how that gets applied into circuits and also into certain applications.
So we have a few of their employees actually working side by side with the postdocs and PhD students in my research group.
They can work very closely and also get the benefits of sharing lab equipment.
It's not just that every 6 months Pragmatic gets some dry report from us. It's a day-by-day evolving collaboration.
We have a good understanding of the types of problems that the other is working on. We have very regular interactions between the teams.
And by having people genuinely talking together over a cup of tea in our tea room, you get much better technology transfer as well, because that's when people really say what they're doing.
And part of our intent is to transfer the methods. So when Andrew uses the roadmap for his work, or if an industrial partner uses it, that's really the benefit and reward for me.
The penny dropped in my mind. I thought, actually, yes, this is a really potentially good collaboration where our aims are actually aligned.
Pragmatic recently has reached a very important milestone in delivering our first prototype products to customers that we're working with, including on greeting cards with Hallmark subsidiary Tiger Print. We are working with De La Rue, the world's largest banknote producer, on security products, and we've also started working with a number of consumer goods companies on how we integrate our electronics into their products and packaging.
All the time you want to be having new ideas that sort of bubble up inside and want to sort of spring out. And working with industry provides you with a way of validating those ideas. So you have a filter there that enables you to direct the research you're doing more effectively and target to those sort of winning cases which are actually going to do something.
Because printed electronics spans a number of disciplines, having people involved from a research perspective as well as from an engineering perspective is very important.
This isn't just something which is purely of academic interest. There really is an impact that's going to benefit not only sort of people in sort of the things they can do around their home and sort of the products they can buy, but actually does something for UK industry as well.
My message from Pragmatic to other small and medium-sized organisations looking at potentially collaborating with the engineering department at Cambridge would be that it is well worth the effort, and hence this is one that can be highly beneficial both from a financial perspective as well as in terms of getting access to expertise that really is world class.
You actually sort of got a feeling that, yeah, what you're doing and what you're getting up to do each day really is having a genuine impact and is doing some good to UK PLC as well.
Dr. Andrew Flewitt and Dr. Robert Phaal of the University of Cambridge Department of Engineering, and Scott White of Pragmatic Printing.
You've been listening to a podcast from the University of Cambridge Department of Engineering.